So, as Kurt and Dave mentioned, I'm going to talk a little bit about protein and amino acid feeding, which has been quite a large focal point within the Van Amberg lab here at Cornell. So much so that we are trying desperately to get version 7 out the door and in the hands of you well-trained nutritionists to break it and let us know what we need to change. So to start, I think what is probably best to do in the next 30 minutes or so is I'm going to talk a little bit about some of the numbers we like to use, whether or not they apply specifically to amino acids and even more so essential amino acids. And then maybe run through, excuse me, some NDS diets just using NDS, using the NDS platform. So I'll switch gears and jump off of PowerPoint and then come through to the NDS platform. So I think this is probably very redundant for everybody here that's talked today, but again, I want to make a point, especially when we're talking about grams of amino acids. So you'll notice, if we're talking on a kilo basis, 0.001 or 0.01 if we're talking tens of grams of amino acids. That's really what we're after when we're discussing amino acid balancing, specifically essentials. So in order to get to that magnitude of precision, particularly when we're talking about ruminant animals on the scale of 1,500 pounds, so maybe about 650 to 700 kilos, we got to make sure our inputs are right. So you guys all know these here: body condition scores, body weights, changes over time relative to the cohort that's within that pen. Are those being adequately described in the model? Particularly is going to account for requirements in growth, especially on the protein side of things, and even on the energy. But when we're trying to figure out what's the optimal supplementation of methionine, lysine, or other essentials for milk production, we got to make sure we're not confounding that with any unintended growth requirements that weren't already there. Other things, especially on the input side, mass balance of feed chemistry. We've talked, Emiliano and others have talked about, Dave too, differences between what's in the feed library relative to what we test in our feed labs. And so obviously the preference would be on using feed lab values, but making sure that if we are incorporating any library values on top of those feed library values, do they actually make sense to the model? And lastly, the inclusion of carbohydrate digestibility rates. Now I say that in an amino acid talk because we are doing some relations on amino acids relative to energy. So we got to make sure that we are accurately describing fermentation rates of fiber and starch and how that would relate to ME predictions, and then more so on perhaps microbial yield and production. Okay, so 4 different metrics here on evaluating nitrogen status in the animal. And obviously the primary metric that we're using still is crude protein. But the model NDS gives us much more specific metrics. Metabolizable protein, which I think a fair majority of people are using, but then we can split that further into bacterial and RUP MP, and then even further still essential amino acids. And if we want to talk about requirements for the animal, it's really we're getting at this amino acid level. Now, by proxy, we actually are associating non-essential amino acids. At this point, it's by more or less by a difference of what we are predicting for essential amino acid supplies off of our MP supplies. But that's work that we can talk about for another time. Regardless, the question is, which metrics are we using and what takes priority when we're talking about nitrogen adequacy. A lot of conversations revolve around crude protein diets that are in excess, so greater than 17%, maybe a number that gets thrown around a lot. And we're trying to work towards diets that are sub 17%. Maybe we're looking at in 16 or 15 range. But the question really becomes is not so much what our crude protein levels are, but what is the quantitative amount that we're actually giving those animals. So rather than a percentage of dry matter, what's the grams per day that we're feeding these animals from MP supply or from methionine or lysine? Or if we want to relate it in other terms, we can talk about mcal of metabolizable energy, which tends to have a relatively good relation, which we've described at the Cornell Nutrition Conference and other ADSA proceedings. So something to keep in mind when we start looking through some of the NDS diets that I'm going to show, which metrics are we concerned about and which are we just going to let be wherever they end up as we focus on other metrics such as amino acid content or metabolizable protein. Further, again, stress this enough is protein and nitrogen adequacy is not a static or isolated event. So I really want to stress optimization in the rumen. So there's ammonia requirements, there's peptide requirements for those bacteria. So making sure that we're hitting those marks without being excessive, which I think tends to be more of the issue rather than shorting the rumen on ammonia requirements. A little bit of discussion maybe on rumen fill, NDF and UNDF relative to intake and what's actually in the rumen, but it's my understanding that that will be covered in later sessions. And then again, as you've heard today, what happens when we start playing around with fermentability and starch and sugars? Are we actually increasing that level of fermentability so much that we start starving the rumen of nitrogen content, or perhaps those fiber digesting bugs, which tend to have a little bit more of a residency within that cell structure compared to the non-structural consuming rumen bugs, which are kind of free floating and have first crack at the nitrogen that's available in the system. So is fermentability causing some unaltered or altered effects on nitrogen status in the rumen? And then we can talk about RUFL content, but I believe Dr. Jenkins and Juliana's done a good job at discussing what what qualifies for good RUFL contents. Lastly, I think to touch on is protein and nitrogen digestibility status. Now, we don't have a protein rate calculator, which is something I think that gets kicked around a lot in terms of its potential, but I want to really leave that alone because that's going to open up a whole other can of worms. But I think it's important to talk about, in terms of digestibility, what's actually available for that animal. Now, I think two major determinants or tests that are provided by your feed chem labs to evaluate nitrogen intestinal digestibility really is the detergent system, or what's known now as the multi-step protein evaluation, or MSPE. Now, when we talk about the detergent system, that's strictly concerned with neutral detergent and soluble nitrogen and acid detergent and soluble nitrogen. And for the most part, that largely follows what we see in feeds that have high amounts or higher proportions of NDF within the diet. So a lot of those feeds, when we're talking about, the B2 fraction of proteins, are really associated with the overall digestibility in forages and those high fiber byproducts. So my takeaway from this is when we're going to submit samples for analysis and we want to know what the nitrogen intestinal digestibility is, the split ends up being between forages and high fiber byproducts, and those what we would call animal sourced byproducts would probably fall under the MSPE test. Now, when I say MSPE, that would be something that was developed within the Van Amberg lab. It is essentially the Ross assay or UN assay, which is subjected to a 16-hour rumen fermentation and then 24 hours of intestinal in vitro digestion with enzymatic mix. And then we look at nitrogen residues after that feed's been filtered. So where I think MSPE really has grounds to stand on is when we're not necessarily looking at high fiber byproducts, or when we're looking at animal sourced byproducts, feeds that may be protected. So if we're talking about rumen protected amino acids, or even when we're discussing heat treated soy products or other high protein products that have been altered out of their raw state to avoid microbial degradation within the rumen. I think that's where MSP really helps in terms of accurate decision making on what the nitrogen digestibility is for those feeds. Just a bit of an example here. You can see there's 4 different feeds that we've fed within one particular diet and evaluated using both the detergent system and also the MSP evaluation. You'll notice there's 2 blood meal batches here, and we received these sequentially within the treatment and fed them out to our treatment cows. Feed nitrogen relatively similar. We've got high nitrogen there. You'll notice, pay attention to this ANDFOM value. We'll talk about that in a minute, but what I really want to stress here is that when we look at the detergent values, what's coming out of the labs, is that we get really no difference in digestibility. There may be 3/4 of a percentage point difference based on crude protein. However, that truly gets exacerbated when we start using the MSPE measurements. This blood meal, this first batch that we've received, either spent too much time in the dry air or it wasn't necessarily a good quality source. But what ended up happening was when we subjected it to that measurement, we saw nearly half of that nitrogen indigested after the intestinal test that we used. We actually formulated based on this batch here, and what ended up happening was we saw a huge drop in protein efficiency and production. However, when we fed this batch back in, it ended up correcting itself. It's also important to note that when we're talking about certain feed ingredients, that you understand what sort of fractions make sense to you. Now, I said to pay attention to the ANDFOM. That obviously, when we're talking about a blood meal that's sourced from an animal, we're not talking about any fiber really. It's negligible. So, what does that truly mean? It's likely an artifact of the ash content within that blood meal. So when I talk about large proportions of fiber, clearly blood meal doesn't fall into that. I feel like that's pretty intuitive, but important to say. Now, the last 2, I think, where we start talking about maybe blurred lines here is we take a raw soybean meal or solvent extracted soybean meal. So again, pretty high in protein content with a reasonable amount of fiber. When we look at the differences here, they're not nearly as exacerbated. However, when we're talking about maybe something that's heat treated, so to avoid degradation in the rumen, we may want to consider more of a MSPE approach to actually look at what happens with intestinal digestibility. So a very long-winded explanation to how we should determine whether we should use the detergent system or the MSPE values that are provided within our feed chemistry. Now, it's my understanding the MSPE values aren't necessarily given to you by default. So it may be a requirement, especially if you're feeding higher levels of animal byproducts or perhaps some other heat treated products, to look at running some MSPE values at your feed, whatever feed lab you're using. To just really hit this point home, this was actually presented at CNC several years ago now, but we had a blood meal ring test that was actually performed on 22 different samples. You can see the batches 1 to 22 here, and the nitrogen content, save maybe this group here, is all relatively similar to one of these, or to all of these ingredients. However, when you estimate intestinal digestibility using that MSP measurement, you find that these values here become highly variable. Some of these values actually, some of these batches came from several of the same processing plants, which begs the question, should we be looking at MSP on a more frequent basis and incorporating that within our diets and feed chemistry when we're describing that in NDS. That likely requires some vigilance just to understand where you're sourcing your ingredients from, and if there may be a warrant to start looking at MSP over a certain period of time, perhaps once per batch, to really understand if we're losing sensitivity on amino acid balancing, that could perhaps be subsequent of alterations in intestinal digestibility. The Ross assay, or MSP, actually is pretty robust. This came out of Paul Kononoff's group looking at the mobile bag relative to this MSP procedure. Now, in this case, we're using hydrolyzed feather meal with different sources, 10 of them to be exact, but you'll notice that the difference in using the mobile bag technique, which is used again as a metric for intestinal digestibility, those numbers are not entirely far off from what we're observing here. They're actually exceptionally well, which does give us confidence in suggesting using the MSP measurements when we're looking at animal byproducts or other rumen-protected feeds. So how do you actually incorporate that into ration formulation? At the moment, with the feed fractions that we have currently existing within the model, there's really not a best way to do this. However, we do advise potentially looking at changing the intestinal digestibilities for the A1 to B2 fractions to 100%. That is strictly, we're talking about the intestinal digestibility fractions, not necessarily the KDs. Those should be left as is, but looking at changing these values here, you'll notice your A1 should be 100%, but your A2 and B1 should also be bumped up to that 100%, leaving your C fraction, or what would be undegraded, at 0. By doing so, you can go back and incorporate that MSPE value in substitution for your ADIN number, which would give you a relatively reasonable MSPE value that you would be observing when you look at your feed chemistry results. A point that I want to stress is that it oftentimes comes up where we look at using MSPE. There is a step where rumen degradability of these feeds is evaluated. However, there are some extenuating circumstances where that may not be advisable to incorporate into feed chemistry values, particularly when we're looking at certain feedstuffs which could induce microbial contamination, or if we have high of the A2 fraction, where we look at high solubility of these feeds. There was a publication that actually just came out quite recently in Antifeed discussing some of the measurements, looking at microbial contamination and how to essentially look at those and discount them relative to rumen degradability. And they actually looked at specific feedstuffs because there can be quite a wide range of microbial contamination that would be attached to those feed particles when you go to digest or filter them, that would increase indigestibility of nitrogen, which otherwise wouldn't have been existed had you just had the digested feed particle without the microbes attached to it. So something to consider if you're looking at incorporating MSPE values into the ration formulation. So assuming you're quite confident in your animal inputs and you are using the appropriate measurements to discuss or describe your feed values, your nitrogen intestinal digestibility values, it's grounds to really start looking at, okay, can we specifically look at amino acid content within this diet? The measurements we like to look at, this was work generated by Ryan Higgs, which was discussed throughout several CNC proceedings, and papers are going to the journal quite soon. But we are really interested in looking at grams of essential amino acids on an energy basis here. It's quite a good log-logistic relationship described, whereas when we incorporate more amino acids into the system, we actually lose some efficiency of use, and that's quite well described when we're putting that on an energy basis. As it stands right now, version 655, which is currently used in the NDS system, is highly robust in metabolizing or in predicting energy predictions for metabolizable energy. Again, the caveat being when we are adequately describing our animals in feed. We want to look specifically as we're taking steps towards these metrics. I like to really look at maximizing microbial protein production. Again, that's quite intuitive for most people. I think particularly within the Northeast, as we're quite reliant on forage feeds for feeding our animals. But when we're looking at perhaps areas maybe out in the West, when we're looking at more byproduct feeds, or perhaps incorporating some of those feeds that do not necessarily have large pools that are digested within the rumen, there's really, I think, an emphasis that should be done on pushing for between 50, over half really of microbial protein should represent NP supply. Now, I think that's really a subject of evaluation for fermentable carbohydrates. We want to make sure the substrates are there to really provide proliferation of those microbial protein pools. So really evaluating fermentable starches and sugars to really try to drive propionate production, microbial NP supply, and we could actually elicit a insulin signaling response at the cow level, which really helps drive milk protein response. That's been quite well described by people such as Reynolds in Reading and Mike Allen out in Michigan State. So really trying to take this step one step further, I think to really look at evaluating our nitrogen status, particularly within the rumen, we really want to emphasize RUM&N balance. So this is a metric that doesn't always get the emphasis that it should. And I really think when we start talking about efficiency of nitrogen use, particularly within the rumen, we really should be paying attention to that. Now, the range recommendations that are by default within CNCPS are quite wide. It's about a 105 to 180%. So you really are not going to get any blaring alarms if you're overfeeding on NH or ammonia, really, other than other metrics which may act as indirect proxies for that balance itself. So my emphasis, really the emphasis within our lab, is to try to take whatever measurements you've got for NH3 balance and minimize it as best you can, between that 115 and 130% range. Really, the lower you get is going to require other attention needs, basically, for you to really be attentive for as a nutritionist, and even to stress to farmers out there. It's really going to depend on compliance with management practices, so consistently feeding out the same ration every day. understanding what the feed chemistry is, because as we move, we've known that as we move below 115%, we really start to look at some deficiencies of nitrogen within that rumen. And if we had any variation in the feedstuffs being fed, that could push us over the edge for nitrogen balance within the rumen. The other thing most important, I think, is important to discuss, and Dave kind of elicited to this just briefly when he had one of his talks today, but really looking at the excretion tab to help improve. What we like to look at is productive N to urinary N. That's really stressing what we've got in terms of nitrogen efficiency, whole nitrogen efficiency for that cow. So again, discussing what are we looking at when we talk about productive N to urinary N. It's all the nitrogen really to put towards productive use. So production, growth, pregnancy, and even reserves are used to make that calculation. And it's all relative to what we're excreting in that model. Now, as you can probably gather, we'd like to see measurements above 1. I think anything below 1 is really not something we should have in this day and age, particularly with the excellent feed chemistry we have and the model's capability at predicting nitrogen within the rumen and post-ruminally. But I really like to see levels between 1.25 and 1.5. Now, for some, that may be a stretch, particularly when we're starting to talk about financial constraints and even inventory constraints. So that's why I really like to see this range here, to try to at least be within that range. I think you're never going to be in that range all the time because things are constantly moving. But to be within that range is probably grounds for a subsequent adequate diet. To put that in perspective, this was published by Mike in 2015. Again, we're looking here at changes in excretion, really, urinary, fecal, and milk. There's a wide range here of some of these diets that were fed, as low as 14% and as high as 17%. You can see the difference here expressed as nitrogen intake on a grams per day basis. Now, most cattle, this slide is probably a little bit older, so we're probably not here. We're probably a little bit more here. You'll notice that when we're discussing productive N to urinary N, we may want to be looking at milk N here to urinary N, assuming there's really no pregnancy or growth functions behind this as the proxy for productive N to urinary N. You'll notice milk nitrogen doesn't really change much here. We're still producing the same amount of milk protein coming out of that cow, and the MUNs may be a little different here, but in terms of productive nitrogen coming out of the milk, not really much change. So really where we get most of our change from is the urinary approach. So trying to minimize excessive sources of nitrogen can help get us to that ideal level that would be greater than 1 and maybe up between 1.2 and higher. So this, again, is just putting this out quantitatively, but the idea is to push beyond that 1 into 1.3. Okay, so with those 3 metrics, looking at productive N to urinary N, rumen ammonia content, and then how are we doing in microbial production. I think post-ruminally, trying to look at the metabolizable, the supply of amino acid per mcal of Me for the cow is the next step to take here. Now you'll notice I have most of all really of the essential amino acids, and there are some that are conditionally essential here that are described. But you'll notice I have them in version 7 and version 655. We've done some work. Most of the recommendations that we have for grams of amino acid per mcal of Me have come out of the version 7 model. Now, we may be not quite to the point where we've got version 7 out. We recognize that. So looking at relating that to 655, these would be the levels of supplementation for grams of each of these amino acids per mcal of Me. Now, there's 10 of them here. When we try to optimize for each one of these amino acids, that tends to be a challenge. Again, when we have feed constraints and price constraints that are being expressed by the farmer, and you have to take that into consideration. So my recommendation, really try to emphasize on methionine and lysine, which we have already been doing. But once we're confident in getting to these levels, these recommendations here, taking that a little further and looking at the rest of these amino acids. I think what would be the next step here is to look at histidine content. There's some literature, recent literature that's come out looking at trying to mimic what's being supplied for methionine and really emphasize similar supply levels to help boost productivity in that animal. So these are the numbers here that we are using within 655 to target for, but then when we're formulating for diets in version 7 within the research lab, we're pushing for those these numbers. The difference here being is we have some other submodels that are accounting for differences in amino acid supply, which is why we've got the difference. Okay, so just before we step in to NDS, I think, again, taking those numbers, really try to look at closing the gap to those targets of grams of amino acid per mcal of Me. That may warrant that you use some rumen protected amino acid products. There are a lot of methionine and lysine products out there, and depending upon their evaluation in terms of digestibility and stability within the rumen, they can help fill in the gaps to hit those marks. Really want to try to target for 1.19 grams of methionine per mcal of Me. And then to take that number and extrapolate it out to lysine content, really try to push for somewhere within the range of 2.6 to 2.7. Now, this recommendation may be a little bit on the higher end relative to what we're used to seeing, but we've got some pretty good evidence from past research studies that really emphasize, which I'll show here in a minute, what can happen when we start pushing those numbers to those levels. Again, I made mention of histidine targets, really to maybe try to mimic these, maybe a little slightly less than amino acid supply. At the end of the day, when we're amino acid balancing, it's all going to come down to vigilance. Setting real expectations for balancing is key here. So maybe not trying to hit all those targets that were just described on the last slide, but make incremental steps as we move closer to that. Again, that's all reliance on proper feed characteristics and management protocols. Last thing I want to note before showing a study that we did and NDS walkthrough is really understanding what is most limiting in the diets that we've just made to target for amino acid balancing. Are the cattle sensitive to the limitations that we think are most limiting, or is there something in the background that we need to really look at? So rather than just saying I've fed a bunch of amino acids to try to improve milk protein, perhaps try to look at, well, what happened to milk fat? Did we relieve some sort of limitation in terms of de novo synthesis within the mammary gland that allowed the cow to produce more milk fat where we maybe didn't see a milk protein response? So I think there's a lot of different incorporations between protein and energy and lipid production, and really try to keep an open mind in terms of what we qualify as productive responses to amino acid balancing. So several months ago, we actually did a rumensin dose titration experiment, which this was never really the intention. We were just looking at different inclusion levels of rumensin and how that improved feed efficiency over time. You'll notice here our dietary inclusions were not overly off on high levels of intake or low levels of intake. We've utilized a primarily corn silage-based diet with some haylage and some other soy products, both raw and as a bypass. We did incorporate some blood. We've got some fat included in here, but then we've also really gotten to the point where we're incorporating some amino acids to meet that mark. And that's indicative here. You can see our crude protein level isn't over 16%, which is reasonable. Fiber's good, relatively decent levels of starch and sugar. When you come down here, however, we were right at the 119 level and about 3.2 grams of lysine. A little bit on the over side of our recommendations. But when we look at these levels and the grams supplied relative to what the cows told us, we actually got surprisingly good responses, both in terms of milk fat and milk protein. I don't have the numbers of what the animals did at the initial start of this experiment, but I can tell you that fat content as a percentage did go up quite high, and we also did see improvements in milk protein output. So there was kind of an additive effect here of both milk protein and milk fat responses. That, I think, is really attributed to making sure the amino acids were there, but also to the effect that we had great rumen health on these animals. The NDF digestibility was pretty stellar, and we had high levels of de novo synthesis for fatty acid in the milk from all of these cows, really. So we were pretty pleased with these results. Okay, just quickly, hopefully I'm not doing terrible on time. Make sure my yes comes over.
Yeah, you're good on time.
Okay. Can you see my NDS here?
Yep. You want to go full screen? Perfect.
Takes a minute here, I guess. There we go. Okay, so main screen here of the NDS platform. Everybody should be familiar with this. I got just a demo diet from Dave. Asked for a demo diet, and he provided with one, which actually is reasonably well when we start talking about the metrics that we're concerned with for amino acid digestibility or amino acid balancing. Excuse me. So again, not a uncommon diet here. About 60% forage on this diet. So typically what we would see in the Northeast for North America. But when we look over at our measurements in terms of macro levels, crude protein is probably a little bit on the higher end. We're approaching that 17% level. So are there steps we can take to help minimize that, get that down lower without sacrificing ME and MP allowable milk? So everything else seems to be reasonable. We're at 100% for both ME and MP allowable. You'll notice here, this is where we're looking for rumen ammonia content within the rumen of the cow. So about 135% here. We have the recommendation between 115 and 130, so we're not too far off the mark here, but there's some opportunity when discussing improvements in nitrogen efficiency. So the other thing to take note of, which we also like to look at, is rumen fill and flux, which can be, it's not necessarily something that's adequately described yet. However, I think the UNDF intake as a percent of body weight and NDF intake as a percent of body weight are good metrics to use. And you can look at that in more detail in the rumen fill calculations. And we're within range of what's been suggested in the literature that actually Kurt has provided over the years. If we take a step over, let's look at productive N to urinary N here. We're about 104 to 1. So we're over that 1 mark, but of course there's opportunity for improvements here. So we really want to take a look at how can we improve that nitrogen efficiency. Lastly, we can pan over to the amino acid tab. If we want to just look at methionine and lysine to start, over here on the right-hand side, we've got grams per mcal of Me. Now you'll notice these levels are a fair bit lower than what we want to see. So there's opportunity here to make improvements on these animals. Now, just several diets to run through very quickly. This diet here, so tabbed over from the original, if I'm going to tab over to the next, there's opportunity actually to make changes to the diet without adding on any more feed sources. So if we want to look just within the variability of the feed sources that are currently being fed and altering the inclusion rates of in which we are feeding these animals, there is certainly opportunity here now. So you'll notice we haven't really changed much in terms of our ME and MP. Rumen ammonia content has actually now gone down about 10 points. So we're within the range that we're comfortable with seeing. And you'll notice that our crude protein diet, this crude protein on this diet is actually 16.3. So we've come down almost 0.5% here. So we're working to make steps towards that. Again, productive end to urinary end has now come up a little bit, probably not within the range that we'd like to see, but with the constraints perhaps of feed ingredients available to us, we're not doing too bad and are making improvements. On the amino acid side, again, we haven't really made strides in improvements here, so that begs the question, should we start now looking at incorporations of other feed ingredients? So taking that one step further, we've got a diet here with the same forage ingredients and a little bit different in terms of ingredients. You'll notice in the previous two, we've actually had cottonseed. That was one of the major components here. We've removed that for the time being, but still kept some blood inclusion. We've actually moved into adding some dextrose, some soy hulls, and 2 different rumen-protected products, both lysine and methionine, as well as some high palmitic fat on these animals. Now again, looking at requirements, we're not really that far off. And again, we've dropped rumen ammonia content down another 7 points. We're probably getting towards the edge here in terms of ammonia content within the rumen. So if we're content with this diet, we're going to have to stay vigilant at the farm and making sure that adherence to the diet is being met. But again, we're still within the range of 117, within 115 to 130. We've dropped crude protein down again. We haven't really changed. I think it's also important to note that we're reasonably similar in ANDFOM content, but we have moved a little bit in terms of sugar, starch, and lipid content, just in terms of mass balancing here. If we take a look at fill effects here, we're within the range. So we've got 0.37. We're a little bit on the lower end when NDS is giving us recommendations between 0.36 and 0.41. But again, there may be some opportunity here to improve fiber levels, particularly on the UNDF side, but we're within the range, so we'll keep moving. This is, again, outside the range on the low end, so you kind of have to play this by ear as you're feeding this out if we have to make changes in that opportunity for fill effects on these animals. Where we really want to pay attention is productive end to urinary end. One more time, we've got at that 1.26 level, which now we're within that range. We're starting to make progress. This is pretty content with where we are. There could be opportunities for more improvement here, but we'll keep moving with where we're at. On the amino acid side, you'll notice we've incorporated about 1/10 of a pound and 6/100ths, 7/100ths of a pound of lysine and methionine respectively. And those quite honestly are reciprocated here when we look at grams of amino acid per mcal of Me. There is opportunity to get lysine up further. Again, that may be a constraint when we're talking about feed prices and what the producer is willing to pay in terms of purchase feed costs. But if that's a case where they would like to see improvements in those levels, you can certainly incorporate that to more of a 3.1 level on those animals. You'll notice histidine, I made mention about that, about 1.08, so we're reasonable there, pretty confident. But again, the other amino acids you're going to have to take stock in and evaluate those relative to the recommendations that we have. I highly doubt that you will be perfect all the time, but having realistic expectations and having a range around those targets is important to make sure that you have realistic expectations for the herd. So lastly, what happens if we perturb this system in terms of imbalances on MP supply? This is probably pretty intuitive to most, but I think it's important to note that we really want to, when we're talking about precision feeding of amino acid balance, we want to make sure that the requirements are as close together as possible. You'll notice we haven't changed much in terms of RUM&N requirements relative to what we did when we didn't incorporate the forage levels that we had here and the diet here. This looks more like what we have in terms of the second diet I showed. However, we see increases in crude protein content, and even more so when we start talking about excretion levels, they drop relative to what we see with this high forage diet, even though we may be getting close to the levels that we need for amino acids. So I think it's important to stress that the reason why I'm showing this is not to just necessarily look at these numbers here, which may look good on the surface, but to also incorporate how we're incorporating or looking at nitrogen efficiency in these metrics, productive N to urinary N, and as well as requirements to those animals. Of course, cost is also a big consideration. That's not really included in this presentation, but it's really important to stress that looking at a diet like this has higher feed costs for those animals, but I'm willing to bet we've kept milk production constant within the animal inputs for each of these diets. But I'm wondering if by increasing our methionine and lysine content to these animals, if we may see differences in component output, which would also improve revenue for this herd, and then shift our income over feed cost for this diet. So, just to wrap up, again, concluding thoughts here. Recommendations really for these grams of amino acids per mcal of ME apply at the moment to lactating animals. There's certainly opportunity for research out there to look at what these recommendations of grams of amino acids may be for other members of the herd, particularly for dry cows. But we have been and are close to working on publishing recommendations for growth requirements, particularly in our young stock animals and some of our primiparous animals, which may have a significant growth requirement associated with them. Dr. Rodrigo Milano discussed this at the last CNC, and they are working in the next couple of weeks to publish that data in JDS. Something else to really consider, milk urea nitrogen contents is going to be a useful tool for you when assessing lower nitrogen contents, particularly in rumen ammonia environments. Really pay attention if we're talking about MUN contents coming back at less than 6 milligrams per deciliter. We really want to make sure that we're keeping a close eye on those and on that group and the diet being fed. Really try to strategize with those lower rumen ammonia diets if we are making changes to our diets in terms of new feed bunks, new hybrids and corn silage that we're incorporating, which may have changes in carbohydrate digestibility. We want to make sure that we're not soaking up what little leftover nitrogen we have in the system. Now, the cow does a good job in recycling that urea, but she can only do so much. And if we really are increasing fermentability on those diets, we may want to consider maybe improving rumen ammonia content for the time being until we have a good handle on how the cows behave with that corn silage or other high fermentable starch ingredients. Lastly, I think what's also important to note is that not all microbial requirements are described. We are recognizing that there is a need to improve requirement predictions for microbes, particularly when we're talking about these low rumen ammonia diets. Branch chain VFAs would be one of them. There is an inherent requirement, especially when we're talking about forage digesting bacteria, to have the appropriate level of branch chain VFAs in the system. So we are looking at that, and hopefully we'll have something in the near future to push out to the NDS platform. Again, just to wrap up, these are some of the points I really would like to stress for these diets as you start to amino acid balance. Really try to confirm nitrogen digestibility for all those feeds that are contributing large amounts of protein in the diet. Look at trying to improve bacterial NP, perhaps targets greater than 55%. Rumen ammonia requirements, look at fill and flux of NDF and UNDF, and then when we're satisfied with those, push on methionine and lysine to start that 1.19 and about 3.13 grams for each on an mcal per ME basis. The others I really would like to stress, if you're going to start targeting those, try to look at those targets that were recommended and set up maybe about between a 15 to a 20% range on them to try to hone in on getting those other amino acids to where they need to be. Lastly, we're probably all aware that environmental concerns are becoming an issue. So I want to emphasize this as much as I can. Look at this number, productive N to urinary N, and try to at least target for 1.1 with the intent of being within that 1.25 to 1.5 range. 1.5 is very hard to get to, but I would say if you can get over that 1.25, you're doing well. So with that, I appreciate the time, maybe a little bit over here, but if there are any questions, please feel free to reach out.